All right, can everybody hear me? I'm usually pretty loud. All right. Well, the mic should be on, but let's see. Okay, good. All right. So we're in the home stretch of Cisco Live. It's always kind of a good news, bad news, because it's always a lot of fun and a lot of excitement. I call it the World Cup of Nerds. But at the same time, I know everybody's ready to get home, too. So for the next 30 minutes, I'll have your attention, hopefully, on ACI, ESGs, and EPGs. The alphabet soup of ACI continues. My name's Joe Reinhardt. I'm a technical content advocate in the Learning with Cisco organization. I cover data center and AI. And my favorite acronym for ACI is a lot of confusing information. Because when it first came out, it was like, I was talking to a gentleman a couple minutes ago, and it's like you got core aggregation access that's pounded into you as a Cisco certified individual. And the first page of training, it shows the CLOS network. And it's like, how do we get from there to here? So sometimes it can be peculiarities with it. But you got the WebEx app that you can interact with me on. We're going to do just a quick intro. We'll talk just briefly about endpoint groups to kind of get level set. Then we'll talk about ESGs. We'll talk about how they kind of look side by side, why you would use one over the other, and then conclusion, and then I will let you all free. All right. So introduction. So how many network-centric implementations you guys, do you have network-centric implementations, app-centric? That's usually what I see in most audiences, by the way. But there's some thoughts in here about that. Anyway, when ACI first came out, the security model pretty much stayed exactly the same until 5.0 when ESGs were introduced. So it's still EPGs and contracts still drive everything. But when you add contracts, the more you add, the more complex it gets, and it can be difficult to manage. So ESGs were one way to be able to address some of that complexity, because TCAM is a precious resource. And every time you put an entry in for a filter in a contract, it consumes more memory. So ESGs are a way to kind of reduce that. But sometimes there'll be questions that'll come up between EPGs and ESGs. I did a talk on ACI deep dive on contracts, and someone asked the question between the difference. And so I thought this would be a helpful topic. So we're going to talk about each and when you would use each, and then we'll wrap up. Everybody with me? So I know the caffeine probably is starting to wear off from the morning coffee. All right, so endpoint groups, EPGs. I don't read slides, because if I did, then I could just give them to you and you could go home and have an hour of your life back. But suffice it to say, endpoint groups. An endpoint, if you've ever read the Cisco contract white paper, is a MAC address and one or zero or more IP addresses. So you're always going to have a MAC address that'll signify an endpoint, and sometimes you can have multiple IP addresses, but that's the definition. And the endpoint group is just you're grouping them together by some kind of function. Maybe it's servers, maybe it's database, whatever. You do it by function. So that's all very familiar, I'm sure. The way you do membership is EPGs can only belong to one bridge domain. When you do your configuration, you have to choose a bridge domain to associate with it. And it can't be more than one. And then obviously by extension, a VRF and tenant. As far as connectivity, especially in a network-centric model, you're using one EPG to one VLAN typically. You're going to do static or dynamic mapping, and the old standby traffic within an EPG is all permitted by default. If you want to go between EPGs, you have to have a contract. By the way, the reason for this, if you ever go into a switch and you look at the zoning rules, show zoning rules, you'll see implicit rules that are already installed that disallow traffic between EPGs. It's like a priority of like 24 or 27 or something like that. And the second you configure a contract, a new rule gets put in that overrides the old rule. That's why this behavior happens. So that's the technical reason why. So if you're ever on network jeopardy, then you're set. All right. And they've been around since the beginning. All right. So as far as functionality, EPGs combine security and forwarding together. Now that'll contracts with ESGs, as we see in a minute. Anytime you want to go between, you obviously have to have a contract. And this is just a quick demo. Well, it was going to be a quick demo. Here we go. So this is an actual fabric, a physical fabric. And the EPGs, there's 3 of them. You have app, database, and web, which is probably in every piece of training material that there is. They've all got IPs and MACs associated with them. There's one that has 2. So the EPGs are already set up. I need to speed my demo up a little bit. All right, so contract relationships, you got your consumer and provider. So the 3 EPGs, and then there's an external EPG with the layer 3 out over here. Later when we do ESGs, this will all be stripped out because you can't have contracts going to EPGs and ESGs to coexist. You will get nasty grams from the controller on it. So here, you show that the contract relationships are intact. You're pinging between web and app, but DB is disallowed because there's no contract between web and DB. Same thing with the rest of this. This is, again, just illustrating the point of the way the contracts are set up. And you can FTP from app to DB. So this is the typical 3-tiered application flow. Is this clear enough? Can everybody see this all right? I know it's a little fuzzy from where I'm standing, so. And you see my wonderful typing skills in here. I'm the king of typos. All right. So now let's look at ESGs. This is kind of what they look like side by side. One of the biggest things about ESGs is they can span bridge domains. EPGs can only live in one bridge domain at a time. You also select it by different attributes. So you got a couple of choices when you configure this. You can select it based on IP, IPv4 or 6. There's also a tag selector. So if you've got some kind of hypervisor integration, you can pick that. Like, for example, if you wanted to do all the Windows servers in a VMware environment, you can use the tag for that. You can also just select the entire EPG. So you have those choices when you create it. And then the other thing that's important to remember is nothing changes with contracts. Contracts do all what contracts have been doing. It's just you're applying them differently. So same filters, same application, same consumer provider, all that's the same. And important thing to remember, you cannot do a contract between an EPG and an ESG. The only exception is with L3 outs because you have an external EPG, you can do it there, but everywhere else you can't do that. All right. You can still use preferred group, which by the way is singular. It's not preferred groups, it's preferred group. But VZNE, preferred group, the other tools are still applicable. You can use them simultaneously. All right. So we talked before about the 3 EPGs. I've got 4 in this example. So it was web to app, as we showed, and then app to DB, but there wasn't anything here. That's why you couldn't ping it. What if you need more contract relationships in this? Now, bear with me. I'm pretty sure none of us would ever really want to do this, but you can see every contract you add adds more complexity, and it consumes more TCAM space. So even if you didn't need 6 to have a full mesh between all these, require 6 contracts. That's a lot to manage. With ESGs, because communication between app and web is something you want anyway, you could put it in a single ESG and then put these other 2, specifically DB, in a separate ESG so you can still control traffic flow between them. And same thing applies in the ESG as applies in the EPG world. Every EPG that's assigned to an ESG can freely communicate without any additional configuration whatsoever. But any inter-ESG communication requires a contract. So it's a shift, but some of the mechanics are still the same. And let me just give you a quick demo on setting up ESGs. So in this one, I've stripped out the contracts. So now they're just freestanding EPGs. You go to the ESG tab, you do a right click, create your Endpoint Security Group, give it a name. You can also administratively shut it down. Here's your tags. You got your tags here. You can do it by EPG or you can do it by subnet. So you've got these choices here. And for this example, we're going to do app and web into one EPG. Click on next. Same thing in creating now there isn't a dev EPG in this example, but it's still, the traffic flow would be the same. So this is DB ESG. Click, and you'll notice that there's only one left because the other ones have already been assigned. You'd have to unassign them to put them in a different EPG or ESG. So now you've got the two, and you're going to apply contracts just like you would. Consume contract for the one, and provided contract for the other. So even though you're grouping the EPGs into these ESGs, the contract flow is still the same. Now, if we go back to do a ping test now, I'll show the mapping real quick. Notice now the EPGs are still there, but the ESGs are being shown as the mapping just like you would with the contracts before. But it's one contract entry instead of two. So even in this scenario, you've already cut it by half. So DB can be pinged from web. DB is able to FTP to app, which is what you want. And then DB can obviously ping web and some other stuff like that. So again, the traffic flow is still very much controlled, but it's a lot more permissive because of the way these things have been grouped. All right. All right. So that's great. Well, how do they compare? So let's look at them side by side. Again, I'm not going to read this slide, but you'll have this for reference. For example, we already talked about EPGs are tied to bridge domains. ESGs can span bridge domains, so by default, they play in the VRF space more. And the only thing I would caveat was, at least as of 6.0, ESGs are not supported on multi-site. Now, I haven't checked the release notes for the newer releases, but that was as of 6.0. All right, so a couple things to keep in mind. EPGs don't go away. You still have to use them for your port mappings. So your static mappings, your dynamic mappings, they're still there. You're just peeling away the security piece for ESGs. The contracts are deployed on all the nodes where the VRF is deployed. And this is a little tricky because if there are ESGs and EPG contracts side by side, the ESGs will supersede it, but you will probably not be allowed to add it if it's still between EPGs. So you got to remove those contracts before you can apply it to the ESGs. And again, EPG, ESG not supported, but this is the one exception with your external EPGs. If you want to do VRF route leaking, it doesn't work the same way with ESG, so you got to be careful with that. And I always feel like I have to say this because I used to have a fabric with first generation hardware in it, which basically you can do almost nothing these days with it. But EPGs are supported on first generation hardware. ESGs are not. Any first generation hardware, you've dodged a bullet right there. But it makes sense because ESGs were introduced in 5.0 and you can't run anything over 4.2 on first generation hardware anyway. But I had, with the contract talk I was referring to about the deep dive on contracts, I had done it on my old fabric. And so I thought, oh, I'll use an IPv4 tag instead of just IP for the filter. And it would disable it. It would configure it, but then it'd be disabled. So it was kind of pointless. So I learned a hard lesson there. So keep that in mind. All right, use cases. When would you use one over the other? All right. Again, the EPGs are not going away. You still have your mappings. But ESGs take over the security function. So the traffic flow between ESGs has been peeled away from the EPGs. And again, you've got your selectors. I've already talked about them. But when would you use EPGs? When you want to keep things simple. If you're using a pure app network centric, it's probably easier in some ways. But if you only have to for a single bridge domain, again, it's mainly if it's just for simplicity's sake. But if you have a lot of contracts and TCAM being consumed, it makes sense to do the ESGs. But security is pretty straightforward. For ESGs, if you need to consolidate your contracts, if you need to deal with TCAM exhaustion, this is going to be one of the best ways to do it. If you want much more granular security across your bridge domains, you do it with the ESGs. And then mainly app-centric deployments would use it. And then there's also some brownfield deployments can be simplified, even migration. All right. So to wrap up, some last thoughts. EPG and ESG look like they're very similar, but they're not. The acronyms are similar, but there's vast differences between the two. Again, ESGs still depend on EPGs for your mappings. EPGs work well if you need simple security, ESGs if you need more granular security. The biggest thing I want you to remember is that you can't do the EPG to ESG contract, at least at this point in time, but ESGs have a lot of flexibility. All right, so in your app, you'll be able to do a survey, let us hear from you. There's a WebEx space if you have additional questions. And you've always got my contact information if you want to ask any additional questions. Just to prove that I am a true ACI nerd, I have 2 fabrics in a data center in Richardson. I finally got those first generation switches replaced, but it's coming back up, and the Nexus, the new Nexus dashboard is going to be able to do NDFC and Orchestrator at the same time. And I really hope to do a presentation in June, fingers crossed, on that actually working. So just, if you happen to make your way in June, hopefully I have something for you. Anyway, thank you for your time. I hope you have a great rest of your conference, and any questions you have, I'm happy to answer. Thank you.
Is it on? So we still have can you hear me? I can speak louder if we still have about a minute. Yeah. So for how many of you it's the last session? Same for me. I'm ready. I'm done. It's a long week. How many sessions did you guys attend? Too many. Hard to count, right? This session hopefully will be a fun one. We'll go fast. It's only 30 minutes. If you guys have questions, we can move on the side. We can continue the conversation. I already mentioned I had another session Monday that was focused on MCP servers for troubleshooting. If you are interested, I'll share that content with you, the recording, the demo, because I think both sessions are complementing each other. At the core of both sessions, we have MCP servers for different network platforms. I will share with you for Catalyst and Meraki, but exactly the same concepts can be used for any other platforms that you guys may have or direct to devices. So let's get started. Gabi Zapodano, I'm a principal technical marketing engineer with the network platforms teams. I have been a network engineer my entire life. I'm still a network engineer. I use slightly different tools for the last almost 10 years, focused on APIs. Last 6 years, part of the business unit for Catalyst and Meraki now. And for the last couple of years, spent quite a bit of time with AI and how to use different tools we can build with natural language interfaces. Very important, if you can, join the WebEx space. If you cannot, ping me, and I'll share with you the PDF. The session has multiple slides that I don't have time to present. I will share the full content with you. Demos, I have a lot more demos that I can share with you if you are interested, and we absolutely can continue the conversation there. We'll talk a little bit about maybe what a hybrid network environment looks like for most of you. And then we'll look at network MCP servers, how to build MCP servers, how to build the tools, how to use them, and then a quick summary. I have few demos as well throughout the presentation. So how many of you feel that this is kind of how it looks when we manage our infrastructure? We have multiple controllers, we have maybe multiple Catalyst Center clusters, multiple organizations from Meraki, we have SD-WAN, we have security platforms. And when we are looking for information, it's not very easy because the information we are looking is fragmented. For some of these workflows that we need, infrastructure as code is great because it can automate across the entire infrastructure. I can configure with an Ansible playbook my SD-WAN, careless error Meraki, firewalls, policies. I can configure everything. But for day-to-day operations where maybe I'm looking quickly for the information about a network device, a client, or an issue, running playbooks might not be the best solution. And that's what we are going to focus is how to build an infrastructure interface, a natural language interface, where we can get very quickly information for frequent questions. Here I'm looking for a specific client. I don't know where it is, in which Meraki organization is, or which Carly Center cluster or site it is. And we are going to try to reuse everything that we have built from infrastructure as code. How many of you have playbooks or Terraform plans or Python SDK, Python automations? If you have those, we have some. If we have them, we can absolutely use, we can very easily show as a natural language interface and use them. Very important, everything you are going to see today, I'm using models that may not be the easiest for you guys to use in production. You can use them through AWS Bedrock, but everything you are seeing is designed for us to learn how to use different models, how to build AI tools. When you are looking to go in production with them, be aware that you need to meet your security policies and privacy data policies when you use AI in your enterprise networks. So I'll start quickly with a demo, and then we'll go to actually building these tools. You can see here, I have a question from Cloud Desktop. I'm using Cloud because they're a really good agent for me to actually not worry about what the agent will do. I'm focused a lot more on development of the MCP server. And I have question about what tools, what can I actually use with a natural language interface. And these are all the tools I have created for both Carly Center and Meraki. I'm going to share the code with you so you can have exactly the same experience. And you can see here, I have client tools, organization, network, issues. So using any of these tools, I can ask a question about a network device or an issue or clients or topology or anything that I have a tool for and get that information using an AI agent like this. So let's start on MCP servers, Model Context Protocol. I asked them, probably most of you have not used or built one. You are going to learn next 20, 25 minutes that it's actually super easy to build them. There are a lot of libraries already available. I am using the libraries from MCP itself, but there are other libraries, Fast MCP client, server. There are many, many different libraries that you can use to build these servers. We have a human. I'm going to interact with an AI agent that has the LLM. That's Cloud Desktop in our case. And using the MCP client and the protocol, I'm going to communicate with the MCP server that will host all the tools. Very important to understand the large language model is part of the client infrastructure. It is not part of the MCP server infrastructure. So you have to control that when you work on your client application and understand how to use different models that meet your business requirements and policy requirements. The communication between the client app and the server is using the MCP protocol. It's not really a standard in a real way that we are comfortable with from an IEEE standards perspective of RFCs, but it is a standard because it's commonly accepted in the industry as one of the options we have to communicate between agents and servers. There are different protocols that you can use. I use STDIO, but you are going to see I have also STDIO over SSH, or if you have a remote server, I have a slide, we have other options as well. The client app is pre-configured with these multiple servers. So I could have, like in my lab, I have 4 servers configured. When the client boots up and you ask a question, it will connect all of these servers and understand what the tools are available. And those tools will be ready for us to ask questions or use them in the way that we need. So let's look at this workflow. I think this is a very important slide for us to understand step by step what will happen. The client connects to all of these MCP servers, discovers all the tools. That's the MCP protocol. Then if I have a question, tell me something like what tools you have, like you saw in the demo, or something about network infrastructure. Then I'm going to submit that question to the client application. The large language model that is part of the client application will understand this is the question. These are the tools that I have available, and will match the question to the tools, one or multiple tools, that will provide me the information that I need. Then the client will send that request to run these tools that are hosted in the MCP server, and the MCP server will execute the tools and return data to the client app. These tools you are going to see could be API calls, could be code that the MCP server is running, could be searches, could be looking through API documentation or documentation of how to configure infrastructure. The results are used by the large language model with the question that was initially asked and provide me an answer to the user. So it's a very important process to understand. The tools execution happen on the servers. The AI interface is in the client. So why would I use direct API calls? Because I can do, if at the end of the day, the MCP servers are actually calling APIs, why would I use an MCP server when I can do exactly the same or sort of with APIs? There are a lot of different comparisons here. I think the ones that are very important is the fact that if I want to use APIs to learn about issues, I need to write step by step, maybe calling 10 different APIs and look through all the issues and understand all the details and loops and conditionals and everything. If I use an MCP server, I don't. It's very easy to add a tool with an YAML description. You are going to see it in a moment, and use the large language model native capabilities to create loops, to make API calls. So it's much easier to actually create new tools based on existing tools. It's just a prompt. It's a question you ask your application versus building tools that are predefined for specific purposes. So you're going to see it's much simpler, but also you can ask any questions based on 20 or 30 API endpoints. So let's take a look at the tool options. Could be a single API. Do you see here any tools that could be one API call, only one API? Because there are some, like sites count. I think that's only one API. Get sites. If I have, let's say, less than 500 sites, it's one API call. So a lot of these tools could be only one API, but sometimes maybe it could be a sequence of APIs. If I'm looking here, for example, for there are some tools where, for example, here I need to get the organizations first and then get the list of networks in a Meraki. So maybe there are two APIs. So if I ask, give me the sites, it would know, let me get all the organizations first and get the sites after that. Let's talk a little bit more. What happens if I have multiple Meraki organizations, multiple controllers, could be Catalyst Center or other controllers from security point of view. We don't want to make it, we need to make it very easy to add new controllers and put them in service. So you can see here in my lab, I have like 4 Catalyst Center clusters. One is not in service, is not enabled for MCP to use. If I change this to true, then the MCP server will use it. You can see here that it shows me that I have access only to 3 controllers because only 3 are enabled. It's very easy from a YAML perspective. I'm going to add our Meraki organization. Next time when the MCP server is used, I have access to 3 Meraki organizations. Let's talk a bit about differences in tools. Imperative. This is something we are all very familiar. I'm going to in this case, for example, it's a policy verification. I'm going to get a token from Catalyst Center. It's written in Python SDK. I'm going to create some CLI templates. I'm going to deploy them to devices. I'm going to check if the deployment completed. I'm going to run some commands with command runner. I'm going to get the output. Step by step, I'm doing everything that I would need to basically implement that workflow. And this was the first MCP server that I created. Took me probably a day and a half to build it. And then I realized that this is not something that we can continue. If I have these workflows already created, I can reuse them in an MCP server. But to continue building tools in this way is not going to be sustainable, it's going to be hard, and it's not going to be very efficient for us. So in the case that we need for configuration, create, update, delete records, this is actually a very good, strong option, because we know when it executes these steps, they will be exactly in that sequence. It's not the only option, but if you need to verify and be hard, basically have very hard rules that these are all the steps required to, let's say, delete something in your infrastructure, this would be a good option. We can use AI code generation to create this, and makes it a little bit easier than how I did it. A lot was hands-on, API call by API call. But there are better ways to create tools, and we can see here. Do you recognize what this is? It's an API specification for an API endpoint. We can see here, it's a little bit hard actually to say, I apologize, but for example, here we have a network inventory tool. We can see the API information. It is basically getting the site count. We can see information about getting sites. I can import this API spec, which is a YAML file, and auto-generate the tools that I need. Remember, I mentioned that MCP servers can write code. And that's how I actually realized how powerful MCP servers are, because I can give the specification for my API endpoints, and the code that I'm going to share with you will load this specification and create the API calls for me. I don't create my server. I don't have any API calls that I wrote. It will be based on the YAML description of my API endpoints. So today I have like 20 or so tools. If I need to create another one, I add it to the YAML description, definition of the tools. Next time I'm running the MCP server, it will create the API endpoint and make API calls for me. And you're going to see I have actually a slide showing you how to create that. So here is a little bit more detail, a little bit easier to see. This is the API endpoint for devices count. These are all the parameters required, the location where the parameters are. This is an API spec that you can collect from Cisco Catalyst Center, from Meraki, from SUN, from a lot of different security platforms. And this is what I need to provide. And this is how, if I ask the question about network devices count, how the MCP server will present me the information. It's very easy to change this. It's something that is already provided to you. If you want to talk a little bit more advanced topics as strategies, how to create this, we can talk after the session, because I learned some lessons of how to actually be efficient when I'm creating these tools. So let's take a look at another demo. So in this case, I'm asking to give me the sites tools and find all the sites from multiple Catalyst Center clusters. I have 3 Catalyst Center clusters in service. So with one question, using natural language, I'm going to get very quickly the tool for site inventory. These are the sites tools that I have, including the site topology, and then it will make the API calls. Remember, it loads the tools definition from YAML, creates the API calls, makes the API calls, and retrieves the data. The data returned from the APIs is what format? Is JSON formatted data, and that is received by the large language model within the client to actually present me the information. And you can see here everything that I have, how many for each cluster, the sites, the address, information about an AI cluster, the locations, everything that I asked for. Why is the topology not included here? I mean, it is a little bit. I have the site hierarchy. Why? Because topology is one of the tools available. Why the result for topology is not included? Because I didn't ask. I asked about what are the sites tools. So topology is a site tool, but I didn't ask the topology. I asked, give me the sites, and that's what it returned. Any questions? Is it hard to build tools? It's very easy. This should be probably one of the easiest things we can do as far as building new operations with APIs, much easier than writing Ansible or Terraform. So let's talk a little bit about what happens from a client perspective and the server perspective, and get a little bit in other types of tools. And I have another demo at the end. So I use Cloud Desktop, I'm sorry. The reason is because it's very, very good. And it uses a model, Anthropic, IOSANE 4, that is very good from a networking perspective. So far I was extremely focused on how do I make the best MCP servers, and because of that, I removed the some questionable answers that some MCP clients or large language models would give me. But when you build your own MCP servers, you have to realize that you may need to use a different large language model. And I started using some large language models that are hosted in my infrastructure. Results are slightly different. It's not very hard to build an MCP client with a hosted large language model, but you need to be aware that sometimes the results you are going to get are not because the MCP server, is because the large language model that you use may not be as good as what you are seeing in some of the demos today. You can see here that with Cloud Desktop, I cannot use any of these other models. So if you have to use another model, you have to use a different client application, and there are libraries to allow you to build a client, an MCP client application with ease. Here is a Cloud Desktop configuration, and the reason I want to share with you is because you can see here that I have three servers that are co-located with my client. So I'm using STDIO from a protocol perspective. They are co-located on my laptop. But if you need to go in production, you cannot really expect everybody in your team to load all the libraries and all the code on your laptop. So you would have to have a server where you run the MCP server code itself. And if that's the case, you have few options here. I can run it in the cloud. It could be on a Docker container or on a VM. Like in my case, it's on a VM. There are different protocols you can use. Streamable HTTP is probably the one recommended. Cloud Desktop doesn't use that, so that's why I use STDIO over SSH in this case. But you do have the option to go production, where you host your MCP servers either cloud or on-prem, and you have your clients from the entire network team accessing those servers as well. Very important. Is this important for you guys? It was for me, but maybe for different reasons. Because we need to know who are the users. Do they have access to the tools? What tools are failing? Do they call tools that is expected? For troubleshooting, for me was primarily, I really needed to troubleshoot when I had issues, because I had issues when I built the MCP servers, and it's very easy to say, oh, this tool failed. Was the right tool that was called? And also telemetry of all the API calls. For you guys, probably understanding from a security perspective has much higher priority, but you have to enable logging, and the servers that I'm going to share with you, the code has logging enabled. You can add more logs. There is a lot of capabilities. You can see here what API call was made, with what parameter, what is the cluster that was sent. And in my case, it's just one user, me, but we can have multiple users making these API calls. So here is how to build inventory tools. So for example, these inventory tools across both Catalyst and Meraki, I'm looking for information about sites, networks, topology, devices, and compliance. And this is a list of the tools for Catalyst Center, for Meraki. And for example, if I'm querying about all the sites for a specific location in Oregon, gives me all the sites that I have from multiple Catalyst Center clusters and multiple Meraki organizations, looks through 2 Meraki organizations and the Catalyst Center clusters and gives me that information. In this case, I filtered through the Portland cluster in the Meraki lab, so it was only looking at a cluster and 1 Meraki organization, but you can make it network-wide. Another tool would be for client details. I will share with you a demo. I don't have time in the session. I ask a question, give me information about DX Pro. That's my video endpoint that I use. I work from home. And it goes through all the Catalyst Center clusters, all the Meraki organizations, all the network and sites, and finds the information about the DX Pro that is in my home network, and gives me information about connected to what access point, performance, health, how long it's connected. It gives me all the information I need. So it's very easy with an MCP server to find a client throughout the entire enterprise network and give you the information you are looking for. How do I write new tools? Because this is important. Yeah, it's nice, it's a YAML file, but somebody has kind of write that YAML file. And the reason I have this slide here is because first time when I started to work with auto generation of tools, I wrote like 3 or 4 tools by hand. And then I decided, can I actually make this process a little bit quicker? So what I did is exactly this. I asked, this is my template for the tools. I want a new tool for getting basically all the alerts from Meraki. And then I'm asking the same AI Claude Desktop. This is my template of how I want the tools to look like. And this is the information I'm looking to build as a new tool. Get the information from the API documentation of Meraki or Catalyst Center could be the same. And then it will create a new tool for me. The YAML description, it's exactly the same. I can append it and use it. And that's what I did last night. I appended this to the code, and it's available to use to give me alerts from Meraki organizations. So it's very, very easy for us to use the same tool that we would use to query information about the network and give me a new tool that I can readily use. Takes me literally 2 minutes, and we have a tool capability that we didn't have before. So, for example, this is showing me more details about the tool, gives me the compliance with my template, because my template is the one that works for me. You can define your own templates and your description and how you want to make it look. I didn't talk about the fact that tools are grouped by different type of domains to make it easier for users. So, building new tools should be no challenge for either one of us. It's a very simple process. And this is how the tool looks. What I would change here, it has a lot of parameters. And maybe it's a topic for a little bit more advanced conversations. Larger YAML files would make it a little bit harder when we have a lot of tools with very long YAML files. Makes it a little bit harder for the large language models to understand what tool to use. But it gives me a very good tool that is actually operational, and I use it. So let's take a look at another demo. In this case, I'm asking to get a list of all devices, clients, and issues from a Meraki lab organization. I don't want to share with you my home network. That's the only reason. And also the one cluster from one of the labs. I have 3 clusters from Catalyst Center. But if I don't filter by organization or a cluster, it will give me all the information network-wide. Now, we need to realize that for your production environment, you are going to have hundreds of sites and potentially thousands of devices and tens of thousands of clients. If you are going to ask exactly the same question, probably it's going to be challenging because large language models have some limitations as far as how much data we can actually consume in a large language model. So if that is the case, we would have to write a different tool where I would say, collect all the devices and start to create a file and save all the information in a file, collect site by site, or maybe I would filter the query, give me information about this site, where maybe I have a handful of devices and maybe 100 clients, and then wouldn't be a problem from a large language model not to be able to handle that data. So be aware sometimes data could be overwhelming from a large language model perspective. So we can see here all the steps it goes through. Now it's step 10 while I was talking. And this is, by the way, real time. I didn't speed up the recording or playback. This is real time, how it will collect all the information. Takes a couple of minutes and gives me everything. If I'm looking for a specific device or a specific client details, would go through the same process, but will provide me all the details, maybe only about that device or client or issues. And you can see here information about the Meraki network. You can see here information about the Catalyst Center, how many devices, clients. We can see issues that are resolved currently. There are no active issues in Catalyst Center, and I didn't have any issues in the last 24 hours with Meraki. So this tool is using only probably a handful of API calls that are presented in a YAML file for the MCP server. When the MCP server needs to make these calls, it will auto-generate the API call, look at the parameters. The large language model understands that I need to loop to get more information about each site, about each basically location, about each network, and be able to parse all the information that we need. So instead of me having to call, because I can make this exactly the same with APIs, but instead of me writing every loop and conditionals, large language model that will understand the question and parse and prepare all the data for us. So this is where you can find the code. Again, this is open source. Please do not use it in lab, in production. For lab, I encourage you to use it. If you are looking for additional features, please let me know. The code includes other capabilities like generation of tools based on the entire Swagger documentation for Catalyst Center and Meraki. So you can actually have additional tools that are not even created. I don't have, for example, a tool for fabrics or VPN site-to-site in Meraki. But if I ask this MCP server, give me the status of a fabric or the status of a VPN site-to-site, or what are all the VPN site-to-sites that you have in your infrastructure, it will go and find from the entire Swagger documentation what tools are available and make those calls, auto-generate the API calls, and make those calls and return data for us. So again, please use the lab. It's not production code. I'm not that good for the production code. So from a summary perspective, I think it's very easy for us to enable AI innovation. MCP servers are transformational in the way that makes it so much easier to embed AI in our network management platforms. And especially when we start to look at multiple controllers, multiple platforms, from security, from WAN, from campus perspective. Some are cloud-based, some are on-prem. MCP servers unify this experience because this makes it very easy for us. I can ask a question like you've seen or here, give me information about everything, and goes and picks up the information from different controllers and presents me that information. I don't have to log in multiple clusters or multiple Meraki organizations to get the data. Be careful with what larger language models you use. Some of them are very good from networking perspective. Some of them may not be. You need to experiment and see what are the right models, but also the ones that you can actually use in your infrastructure. Questions? You can reach me at this email if you cannot join the WebEx. Definitely, I'll share more information with you. Yes.
So with the API keys going to the MCP server, so what determines whether a user is authorized to perform an action?
Yeah. So the question is the API key, like for Meraki, I use an API key. For Catalyst Center, I use an MCP login that the MCP server has. So that is because I'm the only one using. So it's easy for me to skip a step that would be super important for you, which is logging in the MCP client. So if you are actually going in production, what you may want to do is the MCP client will ask you to log in. And those credentials would be what you have access from a tool perspective, because those credentials would be associated to an API key or the authorization token you get from Catalyst Center, and you get access only to specific APIs or specific features or data. So definitely there are steps that I don't have included here, but you should have absolutely an authorization method to allow you as a user to get access only to the data that you have. So for example, if you have a tier 1 NOC, they get access only to read only. They only read information. They cannot write anything, or maybe read only specific information, not everything. So you definitely have to add that from an infrastructure perspective. Any other questions? Is it hard? Shouldn't be. This is a lot easier than a lot of things we have done, but it's so fast. If you are looking like from an MCP server to build new tools, you can build them in 10 minutes. You can have 4 or 5 new tools and have different use cases. Monday, I had another session that was focused on troubleshooting. I'll share with you if you are interested in that content in the WebEx room. It is an entire workflow using the same tool, the same MCP servers. You actually have the code in this repo that would allow you to do troubleshooting and give you event correlation and reasoning and root cause analysis. It is exactly the same MCP server. That's just one of the use cases. We can use the same MCP server, the same tools in a different way. Thank you so much for coming. I know you are tired. I am too. It was a long week. I appreciate you stopping by today. And let me know if you have more questions.
Okay, can people hear me? Yep, excellent. Well, first of all, I'd just like to begin by acknowledging the traditional owners of the land on which we meet today, the Wurundjeri Woi Wurrung people of the Kulin Nation, and pay my respects to the elders past and present. So, my name is Rich Bibby. I'm a product manager with NetBox Labs. I'm based in the UK. And thank you for coming to this talk today. I know it's the last session of the last day, so I wasn't sure who would actually make it, but you're all here, so thank you very much for that. Obviously, we have the WebEx app and the WebEx session details for this. So I'm going to talk initially a little bit about NetBox and NetBox Labs for those people that aren't familiar. We'll look at some of the new integrations that we're building for Cisco network controllers to ingest data into NetBox, and I'll give you a quick demo of that as well. So this is an interesting quote. I don't know if you've heard of these guys at ACDC, but I was lucky enough to go to the gig last night at the Melbourne cricket ground. Brian Johnson actually said, you know, for those about to automate their networks, we salute you. So I thought that was a nice touch from Brian last night. ACDC, they were a pretty decent band. So introducing NetBox and NetBox Labs. So anybody here use NetBox actually? Yep, good, yep, great. We always see this. So NetBox is everywhere, used in networks of all shapes and sizes, all kinds of organizations all over the world. This is a mixture of NetBox Labs customers and also open source users of NetBox too. So who are NetBox Labs? Well, we were founded in 2023. We are the commercial stewards of the open source NetBox project. We have a world-class team that first of all built and led a company called NS1, but also founded the NetBox project. So those of you who are fans of NetBox will know Jeremy Stretch, who was the founder of the NetBox project. He's one of the founders also of NS1. Sorry, of NetBox Labs. I should get that right. NetBox itself is a hugely popular open source project as well. These numbers for things like GitHub stars and contributions and things like that are just huge for an open source project. But you can see the virtuous circle here. So we, as the commercial stewards of the open source projects of NetBox, we reinvest the money we make from the commercial offerings of NetBox for NetBox Cloud and Enterprise back into the open source NetBox project as well. So just some of the basics really. What is a network source of truth? So a source of truth should define the intended state of your network, and it should represent it as well as structured data, which means that other systems can interact with NetBox in a programmatic way to get the data they need to do their jobs. And sometimes adopting a network source of truth can require a bit of a mental shift for network engineers and architects used to documenting networks the traditional way, perhaps in spreadsheets and text files and things like this. So there's a bit of a mental shift required when you move to documenting your NetBox in a proper source of truth like NetBox. Now, I touched on the fact that NetBox is everywhere, and it is fair to say that NetBox is the world's most popular network source of truth. But what are we using it for? So there's a hugely comprehensive data model. So we said that you can model everything from ASNs through to VPNs and everything in between, because NetBox was built from the ground up to model your network infrastructure. It is built with API and integration first. So this is the approach that's been taken. So we've got great interfaces to get data in and out of NetBox. Obviously, you've got the web user interface, but you've also got GraphQL and a REST API. And there are things like event streams and webhooks to also get data out of NetBox too. It's hugely extensible as well. So there are lots of plugins for NetBox. You can customize it. You can add custom objects and custom data types into the NetBox database as well. So it already has a hugely, it's a well-described data model for modeling network infrastructure. But if you want to tweak it as well, you can do that. You can customize it too. And there's an enormous ecosystem of tools that work with NetBox as well. Okay, so this is a journey that we see lots of our customers on. So everyone's trying to get to network automation at stage 3, and some people, most of the customers we speak to are somewhere probably between 1 and 2. 1 being where they are getting rid of their old legacy ways of documenting the network, so the spreadsheets and the text files and things like that, and they're moving to a proper source of truth, so a relational database that contains all of the network information. Once you've got that as your starting point, you then start to move on to stage 2, which is where you really you connect the different types of data in NetBox to each other. So, for example, you're connecting the DSIM data, your physical infrastructure, your sites, racks, cables, and so on, with the IPAM data that we have in NetBox as well. And you can do things like enforcing the consistency of that data and accuracy. So let's say we want to make sure that we always use the same naming conventions for our devices. You can start to enforce that kind of thing within NetBox. And then when you've moved through stage 2, that's where you can do the really fancy stuff, and you can start doing some network automation, which you know, is the goal for a lot of people here at Cisco Live. And with NetBox then as your sort of foundation, if you like, for the data, you can then get your automation tools like Ansible or Python scripts to interact programmatically with that structured data that I talked about that's in the NetBox database. Excuse me a second, just take a quick drink. So, which version of NetBox is right for you? There are a couple of options. Obviously, there's the community edition of NetBox, which is the open source one. But we also have NetBox Enterprise and NetBox Cloud. So these are the commercial offerings from NetBox Labs. And actually, I should just point out we have Richard here with me from NetBox Labs, and we also have a couple of guys from Acqueon at the back here. So Acqueon are our partner here in Australia. And if anybody wants to talk about anything to do with NetBox at all at the end of this session, just grab one of us. We'd be delighted to talk to you. So yeah, you have these commercial offerings of NetBox Enterprise, which basically runs on your own on-premise, you know, on your own infrastructure, but we support it for you. And also you have NetBox Cloud, which is a complete SaaS version of NetBox as well. So a couple of options for you there. Okay, so let's talk about the NetBox integrations that we have for Cisco then. So there's some underlying technology that we're using here for all of the integrations that we're building. The first one is NetBox Discovery, which basically was designed to make it easy to discover the operational state of your network and then ingest that into NetBox in a super simple way. So that's one of the foundations. The other one is something called NetBox Assurance, which is a plugin for the commercial editions of NetBox. And what this does with Assurance is it gives you control over the data that you're ingesting and discovering into NetBox. And what we're looking for here is the drift, so operational drift. So, you know, we've defined the network in NetBox, so we've declared our intent of how we want the network to operate. But what we're looking for with NetBox Assurance is to track where there's a difference between what we've defined in NetBox versus what's actually out there. Okay, so the NetBox Discovery is a suite of tools actually. They all fundamentally run as a lightweight Docker image, and you can deploy this agent in various different places within your network. If you have segmentation, you can drop them behind firewalls and so on. We can do network discovery, so it's powered by Nmap, so we can discover your networks in terms of what IP addresses and what ports are up and things like this. And we can also then do device discovery as well. So device discovery is actually powered underneath the hood by Napalm or SNMP or both. You can enable both. So basically, we're going to talk to your network infrastructure, pull in all the data that we can programmatically from these devices, and then use that to populate NetBox, and then track the deviations between what was already in NetBox versus the actual state of the network. And then at the far end here, we have the last category really of discovery, which is our controller integrations. Now, this is where the integrations for Cisco come into play. So we have Cisco Catalyst Center and Cisco Meraki, which I'm going to show you in a second, that are available. And so what we do with these integrations is the agent running as a Docker image talks to Catalyst Center or talks to the Meraki dashboard, and then ingests all of that network data, the devices and so on into NetBox for us. Now, as I said, we're using an agent-based model here, so we can have different agents doing different things in different parts of your network, all on a schedule that you might want to configure to suit your requirements. But ultimately, they're all sending data of this observed state back to NetBox, and this is where we can then start to check what that state is and if it aligns with our actual intent. Okay, so This is where discovery and assurance really work together. As I said, we're using the discovery tools to connect to the network, whether that's controllers or directly to the devices, and then bringing the observed state of that of the network into NetBox and actually compare it. So this is the key thing here, the delta between the operational state and what's actually in NetBox. Now, if there is a difference between those two states, we want to be able to do something about that. And that's where we have a couple of options here at this point. So it could be that NetBox is correct and there's a deviation from our intended state. So we want to take some kind of action to remediate that. If you're at stage 3 of the network automation journey, you'd probably automatically remediate that kind of issue. But then the other scenario is that the network is correct. Perhaps actually we did mean to deploy some new switches and they've now appeared in the Catalyst Center controller. So we want to update NetBox to reflect that new intended state. But it gives you, this is when NetBox assurance gives you the control over those two different scenarios. Okay, and this is what the NetBox assurance looks like in terms of the NetBox UI. So you can see what you start to get when you're running assurance is this buildup of what kinds of deviations are we seeing from the intended state. Is it a new prefix that's appeared? Is it a new IP address? Is it a new interface? Is it a device, a new device that's popped up? So this is where NetBox assurance gives you that visibility into what's happening on your network. Okay, so when we drill down then, so that's the higher level view of these deviations. When we start to drill down into this data, you can see, here's a blob of JSON data that's been discovered of a new device that's popped up on the network. So you get to review this data, then decide what action you're going to take. And then you can either update NetBox or take some action to remediate that issue. Okay. So specifically for the Catalyst Center and Meraki integrations, I'm the product manager for these two integrations, and they are heading for GA, general availability, by the end of this year. That's the goal, to have them out there. Currently, they're both in what we call customer preview stage, which means that we've got NetBox Labs customers actually testing these two integrations for us, and are giving us feedback. And so we're doing some, any new features we need to add in or any bugs that we need to fix before we move to GA, but it's happening at the end of this year. We're focused primarily on getting and syncing data into NetBox. So we're talking to the controllers and then bringing the data in. And we're looking at things like devices, platforms, IP addresses, MAC addresses, sites, roles, and this kind of thing. And all of this data we can ingest then into NetBox for you. Obviously, you can have multiple agents doing different things, as I've said. So you might have one agent that's doing certain buildings, or a list of buildings, or sites or networks. You can really tailor it, to suit your requirements. Obviously, I'll share the slide deck with people in the WebEx chat afterwards, so you'll have links to the documentation as well, so you can have a read. Okay, so let's move on to the demo. Now, bear with me a second. It's pre-recorded, because I have had issues with bad Wi-Fi events in the past, so it's always better to record it and then I can just talk to the demo. So if I hit play, hopefully we will start to see that. Yes, we're in business. Okay, so within NetBox now, we're going to create some credentials, which are credentials that we're going to use for the client, so we can send data into NetBox. This is called Diode. So we're going to create some credentials here, and then I'm copying them, and we're going to use them in our agent configuration file that's then going to talk to NetBox to send the data in. So we've created these credentials, and we also have a target. So this is the URL that we're actually going to send data into. This is basically the NetBox instance that we're going to send data into. Now, this is the configuration file for one of our agents. You can see this one is the Catalyst Center controller. So we've got a couple of things here we're working with. We've got the target, we've got those secrets that we just created, and we've also got a name for the agent. The name can be anything you like, so you can have different agents with different names. Very simple YAML configuration. Here, for this first time run as well, I'm also using something called bootstrap mode. So we're setting bootstrap to true, and then we're going to run the integration once to actually create some customization in NetBox before we actually run it again on a scheduled basis. So I've actually commented out the schedule in this one, and we've commented out the scope. So here's my environment file. So you can pass credentials in using environment variables, or you can also use HashiCorp Vault. That's the supported integration as well for storing secrets. So you can see we have a simple environment file that we're now going to pass into the agent when we run it. Very simple command to run the agent. So we're passing in the environment variable file here, and I've kicked off the agent. Now, this first run is just an initial one because we're still in bootstrap mode, which means that we're going to, now the job is completed successfully. If I go back to NetBox and I go to the assurance UI, we can see we have some active deviations. So deviation is something that wasn't in NetBox prior to this. And what these deviations are in this case are that because we did the bootstrap run with the agent, we've got some new custom fields, which is customization of the NetBox database that we're now going to apply to NetBox. So that's our first run. So we've got things like the manufacturer, Cisco, and some custom fields that help us model the Catalyst Center data. So just refresh the screen there. We don't have any active deviations at the minute, but what we do have now is the custom fields that allow us to send the rest of the data in from the network that we're going to discover. So in this stage of the demo, what I'm doing here is I'm changing bootstrap mode to false because we're now going to run this on a scheduled basis. So we've set the schedule, in this case, to run every hour. And I'm also going to uncomment the sites here. So we have the scope. So we're saying we're going to concentrate on building 7. So that's just the one site that we want to ingest the data for into NetBox from this agent. So those are the important things that we've updated now. And because we've uncommented the schedule, when I kick this off now, it would obviously run every hour. And I think in this video, you would wait for the top of the hour because that's when it would kick in because that's what we've set. So I fast forwarded this little bit, and you can see the agent is now running. It's hit the Catalyst Center controller and it's ingesting all that data. We can see it's run successfully. We've ingested all that data just for that one specific site. So if I now go back to NetBox, you can see we've got some actual deviations now because none of this data existed in NetBox previously. And you can see these are the kinds of information that we're talking about. So we've discovered a new device, or we've discovered a few new devices actually. So we can start to explore that data. So if I drill down into one of those individual objects, you can see we've discovered I forget what that was exactly, but it's a 9604R. So this is the data that we've discovered from this device. And then what we can do now is think of this as like a first time run. We're just getting the data into NetBox initially. So we select all of these deviations and then apply them to the NetBox database. So we'll just let that apply. Okay, so now the data has been ingested into NetBox and we can start to explore it. So you can see a site related to this Catalyst Center are a bunch of objects now. So we have a bunch of devices, a couple of sites, and some IP addresses as well. So we have a look. I'll filter, I think, on this particular site, and we'll select one device. So you can see for this 9300 switch, you can see we've got the primary IP address, the platform we're running, the role, and the status. And we've also got this that customized information as well, things like the serial number, stack IDs, and things like that. And if we start to explore our interfaces, you can see these are all the interfaces that we've pulled in. So we have the interface type, the descriptions, and so on, and the speed. So that was a quick view of the Catalyst Center integration. The Meraki integration works in exactly the same way. But what I'm going to do now is switch to another instance of NetBox to actually just give you a quick demonstration of pushing something back the other way. So I'll just pause it here for a second. So with NetBox, I mentioned there are ways of getting data in and out. So what we're going to show you here is actually a way of getting data out of NetBox and pushing it to Meraki in this case. So quite a simple example, but what we have is, first of all, is an event rule in NetBox, and we have one called Meraki switch port updated. So what this is we're looking for events where we're updating an object in NetBox, which is a Meraki switch port. And then when that happens, when that event happens, what we're doing is then we're triggering a webhook. Now, this webhook, you can see, is making simply just, it's a webhook that's firing to the Meraki dashboard, and we're pulling in data. We've used a template here, so we're pulling in data from the NetBox database. And what we're actually doing here is the name, the status of the interface, the type, and what VLAN we want that interface to be in. So when that event happens, when we update the interface, we're going to make that API call. to the Meraki dashboard and update the interface. So just to show you the data we're working here from a Meraki perspective, you can see we have this switch with a bunch of interfaces. And what I'll do is actually, so I think we're going to update interface port 2. And I think, yeah, if we switch back to the Meraki dashboard, if I find this actual device, you can see for the configuration on this interface at the minute, it's a trunk port native VLAN 1. So it's a very simple kind of out-of-the-box configuration at the minute. So what we'll do next then is in NetBox, we'll actually go into that device. We'll go to that port and I'll edit it. And what I'm going to do is then change the VLAN assignment and the description in a second. There we go. Okay, so we're editing the interface in NetBox. So first of all, I'm going to add a description saying DMZ. Then I'm going to update the VLAN assignment as well. So from the, I was struggling to scroll to the right bit then. So we're going to change the mode of the interface to an access port. We're going to select a VLAN from our branch office VLAN group that we have there. It's VLAN 100. And then we just save that object. Now that's the event that's going to trigger our webhook to fire to Meraki. Okay, so and the way we can track our events in NetBox is to look at the background queues, and just to show you kind of the back end, you can see, yeah, this is the task that's completed. That's the payload that was sent, the full payload that was sent in the API request. Well, this is the data that's associated with it from a NetBox perspective, rather. And then in second, if I switch over now to the Meraki dashboard and just refresh the screen, we'll see, ta-da, we have now got port 2 with the description is DMZ. It's now an access port and it's in VLAN 100. Sorry, VLAN 100. So that just gives you, you know, hopefully a flavor of the kinds of things you can do from NetBox. There's ways of getting data in, which is the NetBox discovery, the controller integrations, and there's ways of getting data back out and pushing it the other way. Okay, so what's next then? I would say if you want to get your hands on NetBox, sign up for the NetBox Cloud free plan. So there's a free tier with NetBox Cloud. It's perfect for small networks, sort of targeted use cases or lab environments. I think it's you can get 100 devices in there, 500 IP addresses, and make up to 10,000 API requests per month. So sign up for the free plan. You have a NetBox Cloud instance up and running in about 60 seconds. It's by far the easiest way to get started with NetBox, and then you can really try out like the full power of NetBox as a secure in a secure hosted SaaS platform as well. So just to give you a taste for that. And I think, yeah, I'll leave that slide up if anyone wants to make a note of that URL. As I said, thank you so much for attending this. I wasn't sure how many people would get here for this last session on the last day, so I really appreciate your time and coming out. If you want to talk to any of us, any of the team here about NetBox, please grab us now. We're going to be around for it until they kick us out of the world of solutions. So yeah, thank you very much.